right, so we're going to begin with adding like signs. And that basically means we're either adding positive. Oh, that's not a positive. Plus positive, or negative plus negative. And today we're going to look at this using models. So we're going to look at this using models. All right. So the first thing we need to do when we're looking at models, we're going to start using the color counters, or here we're going to call them the shaded counters. All right. So this is our key. So that means if we have an unshaded block, that's going to equal a positive 1, or 1 positive. But if we have a square that is shaded, that's going to represent a negative 1. So that's going to represent a negative 1. Okay? So if I have the following problem here. All right, let's say we have the following problem here. Of course, we can represent both parts of this model. So this is 2 positives, or positive 2 plus 4 positives, or positive 4. And of course, when we put all of them together, we can represent that as positive 6, or 6 positives. All right. Similarly, if we do the same here, and here I'm going to use circles. Then I'm going to shade them. All right. So knowing that each one of these represent a a negative 1, I would have negative 6 plus a negative 3. Negative 6 plus a negative 3. And of course, when we put all of these together, since they're like signs, that's going to equal a negative 9. Okay? Now, if I were to use a number line, that means since they're all like signs, the arrows that represent each value will be moving in the same direction. For example, let's say I have 2 plus 3. Let's say I have 2 plus 3. So on a number line, I can start with all positives. That's 0, 1, 2, 3, 4, 5, and add one more, 6. All right, so of course I need to represent both of these numbers, both of these values. So starting with the 2 first, starting from 0, since it's a positive 2, I'm going to move and show an arrow that represents 2 moves or 2 units to the right, and I'm going to stop at 2. So this represents the 2 here. Then I need to represent the second value here. That's the 3. So we have 1, 2, and 3. So this is what this model would look like on a number line. And of course, where that arrow stops, that's going to be the value or your final answer. Of course, 2 plus 3 is 5. Okay. Similarly, if I have negative 3 plus a negative 4, that equals, well, since they're like signs, that means the arrows representing each one of these values will move to the left because both of those are negative values. So I'm going to start with my 0 to the right, and then I'll have -1, -2, -3, -4, -5, -6, -7, and -8. All right. So I'm going to represent the first value, which is -3, meaning starting from 0, I'm going to move and write an arrow that stops 3 units to the left of 0. So this represents -3. And then here we have to represent the second term. So continuing where we left off, we're just adding 4 units to the left because it's negative. So that's 1, 2, 3, and 4. And of course this is -4. All right. And wherever that arrow stops, that's going to give us the value for this problem. Of course, the arrow stops at -7. So that's -7. All right. So now that's for like signs. What about if we have different signs? So now we're going to be adding, different signs. All right. So there's something when using the counters that we introduced. It's called 0 pairs. And a 0 pair is basically when one positive plus one negative equals 0. Okay? And this looks similar to if we have the counters. So that'll be a positive plus a negative. And that's going to equal 0 because they cancel each other out. So one positive and one negative, they cancel each other out. All right. So now let's look at a problem where we have different signs using counters. So here we have all right, and then for our second value we have all right. So here, of course, we have an unshaded, and each one of these represent a positive. So we have 8 positives, or positive 8. And we can just put that as 8. Plus, then we have 6 negatives, so that's a -6. And I always put my -6 inside a parenthesis. All right. And now we can look to create 0 pairs. And 0 pairs mean we have one positive and one negative. So here we have one 0 pair. We have another 0 pair. Another. And we have 2 more 0 pairs we can create because they're just canceling each other out. And whatever we're left with is going to be that answer. So that's 2 positives. Okay? Again, we create 0 pairs, and whatever we have left That's going to be the answer. All right. So if we look at the following.
Mr. Davis, I'm still confused about the zero pairs thing.
Okay, what about it are you what are you confused about?
Sorry, I was catching up on the